Hello everyone, this is Saida Javeria. In this video, we are going to discuss about data preprocessing for ML project. What is data preprocessing? The process of preparing the data for analysis. The technique of preparing, cleaning, and organizing the raw data to make it suitable for a building and training machine learning models. In real world, data is incomplete, inconsistent, and likely to contain many errors. We have the following preprocessing techniques as data cleaning, which includes noise, outliers, missing values, duplicate data, dealing with categorical data. Following up with data integration, data transformation, data reduction, sampling, imputation, discretization, feature extraction, splitting the dataset into training and testing sets, and scaling the features. Following up with we have types of data. There are four types of data, which is numerical data, categorical data, time series data, and text. The numerical data include discrete data such as date, number of students in a class, and continuous data such as cost of a house in decimal. The categorical data have three types in it, which is nominal, ordinal, and dichotomous. In nominal data, we have as gender. In ordinal data, we have grades of a student, splitting it into groups. And in dichotomous, we have cancerous and non-cancerous. In time series data, it includes sequence of numbers collected at regular interval over some period of time. In text, we have words. Now let us discuss about the quality of the data, which includes accuracy, human or computer errors, incorrect formats, completeness, consistency. Data preprocessing is divided into four stages, such as data cleaning, data integration, data reduction, and data transformation. Starting up with the data cleaning. Data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set. The main motive is identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data within a dataset. It also checks for the duplicate observation, irrelevant observation, fixing structural errors such as noise, outliers, missing values, duplicate data, and dealing with the categorical data. What does noisy data mean and how it is being handled? Data with a large amount of additional meaningless information in it is called a noisy data. Noisy data can be handled by following three methods. Those are binning, regression, clustering. Now talking about the outliers. Outliers are extreme values that fall a long way outside of the other observations. For example, in a normal distribution, outliers may be values on the tails of the distribution. An outlier is an observation that lies an abnormal distance from other values in a random sample from a population. Here are some techniques for finding out the outliers, such as box plot, scatter plot, z-score, expectation maximization, linear correlations, principal content analysis, cluster density or nearest neighbor analysis. And the last we have interquartile range. Now let us talk about missing values. It is the removing the training example. It includes filling in missing value manually, using a standard value to replace the missing value, using central tendency mean median mode for attribute to replace the missing value, using central tendency mean median mode for attribute belonging to same class to replace the missing value, using the most probable value to fill in the missing value. Here we have the techniques of dealing with the missing data. drop missing values or columns or rows, imputation, and a slightly better approach towards handling missing data is imputation. Imputation means to replace or fill the missing data with some value. There are lot of ways to impute the data. A constant value that belongs to the set of possible values of that variable, such as 0, distinct from all the other values. A mean, median, or mode value for the column. A value estimated by another predictive model and multiple imputation. Now let us continue with the second stage of data preprocessing, that is data integration. It is a combining of data from disparate sources into meaningful and valuable information. It can also be said as data from various sources and technologies. It includes multiple databases, data cubes, or flat files issues. The issues faced by data integration is schema integration, redundancy, detection and resolution of data value conflicts. Following up with the third stage of data preprocessing, that is data reduction. Dimension reduction compresses large set of features onto a new feature subspace of lower dimensional without losing the important information. Dimensionality reduction can be done in two different ways. By only keeping the most relevant variables from the original dataset. This technique is called feature selection. By finding a smaller set of value by finding a smaller set of new variables, each being a combination of the input variables containing basically the same information as the input variables. It can also be said as the process that reduces the volume of the original data and represents it in a much smaller volume. It ensures the integrity of data while reducing the data. It includes missing values ratio, low variance filter, high correlation filter, principal component analysis. And the final stage is data transformation. The process of taking data stored in one format and converting it to another format is called data transformation. Data sets in which different columns have different units, like one column can be in kilograms while another column can be in centimeters. It includes smoothing, attribute or feature construction, aggregation, normalization, discretization, concept hierarchy generation for nominal data. There are four types of scalar in data transformation, that is min-max scalar, max, absolute maximum scalar, robust scalar, quantile transformer scalar. And also we have log transform, unit vector scalar or normalizer. In the log transform, take the log of the values in a column and use these values as the column instead. It is primarily used to convert a skewed distribution to a normal distribution. The log transform data follows a normal or near normal distribution. It allows reducing the impact of too low values, reducing the impact of too high values. The unit vector scalar or normalizer. Normalization is the process of scaling individual samples to have to have unit normal. Normalizer works on the rows. If we are using L1 norm, the values in each column are converted so that the sum of their absolute values along the row is equal to 1. If we are using L2 norm, the value in each column are first squared and are added so that the sum of their absolute values along the row is equal to 1. Now coming up with some techniques for handling the categorical data. First starting with find and replace, label encoding, binary encoding, one hot encoding, and ordinal encoder. And here is the code for handling the categorical data. Now let us discuss about sampling. Sampling is done to draw conclusions about population from samples. It enables us to determine a population's characteristics by directly observing only a portion or sample of the population, which represents in the diagram. There are four types of sampling: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. And here is a concept called resampling. Resampling is a series of methods used to reconstruct your sample data sets, including training sets and validation sets. It also includes cross-validation and imbalanced data set. Example, in an utilities fraud detection data in an utilities fraud detection data set, you have the following data. Total observation is equal to 1000, fraudulent observation is equal to 20, non-fraudulent observation is equal to 980, and the event rate is equal to 2%. There are few resampling techniques as follows: random under sampling, random oversampling, cluster-based oversampling, informed oversampling. And the last subtopic to discuss is discretization. Discretization is to divide the attributes of the continuous nature into data with intervals. It includes binning histogram analysis, in which histogram analysis has equal frequency partitioning and equal width partitioning. Equal frequency partitioning is a partitioning that the value based on their number of occurrences in the dataset. And the equal width partitioning is the partitioning the values is a fixed gap based on the number of bins, that is a set of values ranging from 0 to 20. Clustering is the group that clustering is grouping the similar data together. And this is the end of the video. Thanks for watching.